There we go. All right. So, last class for the chapter, holiday tomorrow, test day is Thursday. And as usual, no Zoom class on Thursday, but I'll be hanging around both tomorrow and Thursday, waiting for your questions and asking for help, things like that. All right. So, I put this list together, a couple of classes ago. It seems like lots of little pieces that we cover in this chapter, and they build on each other, like most things do. Excuse me. So to start with, the first thing on the list was plotting points. Are you comfortable with, if I give you -6.5, you could put that spot on the graph. I hope at this point you're okay with that. Okay. So you just jump in and say, hey, can we do some of that? As I go down this list. All right. Then sort of working the other way around. If there's a point on the graph, can you count the squares and figure out what the coordinates are for that point? Say like my basic graph grid where it's 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 might not be too difficult. I would just encourage you to really be careful if you're looking at one of those application kinds of problems where it might be going in hundreds, or maybe they're only showing you a number like every other line, and you got to be careful to count. Just read the graph accurately, read the graph carefully, okay? All right, then the next thing, we were presented with these things we call linear equations with two variables in them, x's and y's, and given a point and asked to verify whether it was a solution or not. If I've got an equation and I have a point, I told x, y values, right? Ordered pair, right? X and then y. Is it true? Does it make the equation true? Is it a solution? Can you plug those numbers in and simplify it and figure out whether it worked or not? All right? So verifying a solution. And kind of the next step from there, problems asked you to come up with 3 solutions, right? What I call those T charts, the X and the Y columns. And here's an equation, and you get to pick some points, pick some values, pick some numbers to plug in for one variable and figure out what the other variable needs to be. All right, so I'm just asking you to remember those ideas, those kinds of problems you did before. You feel comfortable with being able to do that. Find 3 solutions to this equation. Somewhat kind of depended, what kinds of points you chose, maybe depended on what the shape of the equation was and what kind of numbers were in that equation. I think I'll just take a second here to point out what I was talking about. If I had an equation like this, and by now at this point in the chapter, we say, oh, that's in slope-intercept form. We know that from the end. But pick 3 values to plug in for one variable and find the other variable. Here's the one where I would usually say it's easiest to pick some nice, simple x values. There we go, mixing it up. Pick some nice x values and do the work and figure out what the y is. So, just some simple numbers like that to plug in for x and see what you get for the y. And just say if I put in a 1, I'd get 3 times 1 plus 5. I get y equals 8. That makes that an ordered pair solution. Right? That's one solution. So just being able to do that, pick some numbers that will go in there and that you can put in there and calculate the other value. If it had a fraction for that slope value that we know now, here's where I would have said, well, let's pick some numbers that work nicely with that denominator so that when I multiply it, I get an integer, a whole number. So here I might have said something like that, or any multiple of 4 would be a good choice here, right? Any multiple of 4 works pretty nicely there. And then I could stick in that 4 for instance, and get y equals 3 minus 2. So if it's a 4, I get a 1. I just do that real quick as a review here, but it's always slowing down. And then, all right, so that's kind of why I stopped and did this. Remember, if it's a fraction, pick some nice numbers that work with that fraction. And even next on my list, well, asking for the coordinates of the intercepts. Remember, if it was in what I started calling the standard form, here picking some numbers to come up with for solutions. Oh, look, if I put in a 0 for x, that 4 divides nicely into 12 and I can find the y. Or if I put in then a 0 for the y, that cancels out, and so the 2 divides nicely into 12. The zeros are often good choices for problems in this shape. But what am I finding when I do that? Right? If I put in a 0 for x, divide by 4, I get y as a 3. If I put in a 0 for y, that becomes 0. Divide by 2, I get x as a 6. Those are the intercepts, right? When there's a 0 for one of the coordinates, we are finding the place where the graph crosses the axes. Now we say the one that's 0 is the other one. So here, x is 0 means it's the y-intercept, 0, 3, or 6, 0. Now there's 2 points. That's an easy way to graph that line. Find the intercepts. If it's in that shape, using that intercept method to graph that line is often very convenient. A good choice. All right, using the intercepts. Going the other way around, if I've got a graph, oops, and I'm going to say it's up there. What are the intercepts for this graph? What's the x-intercept? Well, you got to know which one you're talking about. Oh, the x-intercept, that's where it's crossing the x-axis. So that must be 1, 2, 0. Right? What's the y-intercept? It's up here, right? And I call that 0, 3. I keep it, miss my dot. Okay. Finding the intercepts from the graph. Can you just read the graph and come up with the coordinates? Understand the idea of intercepts. Going down my list, calculate the intercepts from an equation. Well, I just did it for an equation in that standard form, but I suppose if I had an equation in this shape, if I want to find the intercepts, I hear the fighter jets outside practicing in our valley. You know, you get the little fighter jets that come and train in our area. If I'm looking for the intercepts and it's in this shape, I still want to put in zeros. That's what I'm looking for. Right? I still want to put in a 0 for x to see what the y is, to find out you know, what the y-intercept is. 0 for x means I'm going to get a -5. If I put in a 0 for y, this one, well, if you're just looking for the coordinates, it might not work out as nicely. Right? If I put in a 0 for y, I'd add the 5, divide by 2, check, anybody else? Nope, nobody else is waiting to get in. Oh, okay, the x is 5 halves, so 2.5, okay, that happens to be the x-intercept. It's a fraction, but it can happen. Luckily, they just want you to find that point and not do a whole lot of extra work with a fraction, I guess you could say. But if you're looking for intercepts, you're sticking in a 0 for x and a 0 for y. Find the intercepts. Okay. So far, so good? And, all right, determine the slope from the graph. Yeah. Get my ruler out here, make a little better looking graph here. Determine the slope from the graph. Well, here's to begin with, it's important to know what size your units are. All right. Slope, rise over run, just count the squares, right? Find two good points. Now on my graph, because I don't have a full graph grid, I'm relying on these intercept points. That's not necessarily going to be the case on one of those like mom grids. You might find that that line crosses here and it crosses here. And then you'll have to figure out, well, count from there to figure out your rise over run. Here I would say from this point, I went up 1, 2, 3, and I went over 1, 2, 3, 4, 5. Here I'd say that has a slope of 3/5. It's going uphill, I expect this to be positive. If it was going downhill, I would expect it to be negative. Or if it's an application problem, all right? I'm making something up here, right? But it's an application problem that's got a graph with bigger numbers on it like that. Still might be, I'll call it X and Y. And, so if I've got a point, let's pick one up here and one down here. What's the slope of that line? And so basically my lines here, you can read it, are 50s, and I only outlined the hundreds. 100 blank, 200 blank, 300. And here I went 5, 10, 15, 20. So all my lines there were 5s. So from this point, I went down to this point, right? My rise over run. Well, I started there, that's 250. Down to here, I went down 250. Okay, went down 250. And from here over to there, I went over 25. So I'm making a point of watch out for the units on your graph if it's not just a simple 1, 2, 3, 4, 5. Here I would say, well, that's then negative and divide, what is that, negative 10. Negative 10 is that slope. Simplify the fraction. Oh, crap. So being able to read the graph and determine the slope. What's the slope of a horizontal line? Answer that in your head right now. What's the slope of a horizontal line? Beautiful horizon. How much is this slanted? Right? Horizontal line. Gotta know. What's the slope of a vertical line? What do we say for that slope? If we were writing it on paper, we might say undefined. Mom's going to say it does not exist. And they usually give you that instruction to say, if it's undefined, say that, or if it does not exist, write DNE. Vertical versus horizontal. Somehow you gotta be able to keep that straight in your head. I keep saying that because unfortunately I have seen people over the years get them mixed up. Okay. Yeah. All right, horizontal, just knowing then what the special ones, I called it, I made some comments on the forum about one of the 4.5 homework problems. Somebody prompted me with a question. Calling those one of the special ones, the horizontal and vertical ones is what I was getting at. If I've got, if I know 2 points, is that what I'm saying? Yeah. I've got 2 points. I've got 2 points. Can I calculate the slope of the line that goes through those 2 points? You need to know the slope formula, how to use that more calculation-based version here. The difference in the y's is the rise, right? Rise is up and down. That's the change in y. Versus the difference in the run, or the change in x's. You got to know this formula in your head, how to use it, how to find the slope if you just know 2 points. We did this a couple times now just to practice. Some of us, it seemed a while ago, made some mistakes with our negative numbers. Difference in the y's. Make sure you're choosing the y values to put on top. Say, it doesn't matter which one's first, right? 7 minus happens to be minus a negative. Making that up on purpose with a negative. Started with the 7 here. That is, started with this as the y value, so I need to start with the corresponding x value. -3 minus a 6. What do I get for the slope between those 2 points? Subtracting a negative is adding. That's really 7 plus 4. But this is minus and more minus. -3 and minus 6 more is what, -9? Probably put that negative sign out front and call the fraction a -11/9. Slow down. It's about time somebody say, where did you get the 3? So far, so good. Didn't mess up anything yet, I think. Okay, so if you have 2 points, you can calculate the slope. It's kind of what I just did with the graph values also, especially in an application. Get 2 good points on your graph. If you look at the graph, you can count the squares, but you could do it with the formula also. Okay, is that all right? You keep going. All right, you just, as always, slow me down. All right, so that was lots of different ways to find the slope. Read the graph or do the calculation if you know the points there. Then we started graphing the lines if we had the right information. So, graph this line. How do you want to do it? And you notice on my review sheet, colon. And then there's a list of different ways you could do that. Beginning of the chapter, we just did this. You could do that. You could just come up with 2 good points and graph that line that way. Right? Plug in some x's and find the y's and come up with 2 points. If it's in a certain shape, I might say, well, what's my easiest way to graph that one? I think I'll use the intercept method. Plug in a 0 for x and see what I get for y. Plug in a 0 for y and see what I get for x. Now I'll know where the intercepts are. But eventually, we then knew the, I'm just checking my list, make sure I don't forget anything. What if I know not even the equation, but I want a graph? What if I know a slope and a point? I know a point and a slope. Can you graph that line? Kind of working backwards when we were trying to come up with the equation. That's what we needed, a point and a slope to write an equation. But just to graph it, well, let's find that starting point. -2 and up 3, there's a starting point. And I can now count from there using the slope to find a second point. So if I go up 3 and over 5, right? 1, 2, 3, 1, 2, 3, 4, 5. Roughly over there would be a second point, and use that pencil tool to graph that line. So if I know a slope and a point, can you graph the line? graph the horizontal line that goes through that point. And you graph the horizontal line going through that point. Horizontal, is that the one that goes through X or is that the one that goes through Y? That's what you got, horizontal. Oh, it's all on the same Y value. Well, what Y value if it's going through that point? Y equals 3, kind of getting ahead of ourselves, but there's that equation, right? Horizontal line through that point. Oops, I missed a bit, but goes through 3. What's the other one? Graph the vertical line through that point. Vertical. Always the same X. Oh, so -2. Here's the vertical. And again, there'd be the equations. It's kind of farther down my list, but here's the equations for those two. A horizontal line through that point, a vertical line through that point. If I'm lucky enough, you know, when I gave you a slope and a point, right? Plotted that point and then found a second point. Not quite on my list, but if I give you this equation, ask you to graph it, well, we can pull out the slope and the special point, the y-intercept is -2, using the slope-intercept information and a slope of 4. And call it 4/1. You know, so it's just another variation, but a nice one of I know a point and I know a slope, and now I can put that point on the graph and use the slope to, you know, go up 4 and over 1. I can graph that equation. Okay, so it's all about if you're given the right enough information, can you graph it? Go in the other direction. If I'm given enough information, can I write the equation? You will be asked to put final equations in that slope-intercept form. Whatever you start out with for some reason, make it look like that shape to begin with. I don't even think it would mind, the program would mind if you did, we've seen a few examples, especially in the word problems, where that's just addition. It really doesn't matter the order there, right? The fixed amount is first, plus how many times X. I hope that hasn't confused you much on, like I say, most of the application problems you see it written like this sometimes. It's the same idea. But if I know certain information, that's supposed to look like, boy, that's the perfect, nice information. There's a slope. I always need a point, and I need a slope. Right, to get going, plugging it in. Well, there's a slope. There's the very special point. X is 0, so it is the y-intercept. Here I'd say y equals -2x plus 6, and I'd be done. I think I noticed Mom always kind of does this for you, and then it leaves you the box. Don't type y again. Maybe always preview your answer. I think if you did type y again, it's a bad syntax or something. Preview your answer. Here I would just not put in this. That makes sense, right? Details about how Mom works. All right, so that's saying, all right, I have a point and a slope, and I have a very special point that makes it easy. You might say, I have the y-intercept to start. Then, well, what if I had a point and a slope, but it's not the y-intercept. Write the equation. The technique that I emphasized and presented mostly was solve for b. I have an x, I have a y, I have a slope. I can plug in for these three letters and solve for the missing b. Then I will know the intercept. And I can then go back and write slope-intercept form. Here I would say, okay, if y is -2, I'm sure you don't mix them up. Slope 1/2 times a 4 plus b. Solve this equation now. It just happens to be a b that's the missing variable. And you could get 4/2 or cancel the 2's first. And -2 equals, yes, 2 plus b. So I'd subtract the 2 from both sides. And get that b was a -4. 0, -4 if I put it in ordered pair form. All right, watch out for that in instructions. If they ask for ordered pair, you need to write it like that. Excuse me. Then I have to go back and say, now I know the slope and the y-intercept. I can say, there's the equation you're looking for in that shape. Doesn't really use this point anymore. Once I used it just to find the intercept. The next sort of level of difficulty, all right, I'm going to just keep moving until you do that again or something, all right? The next level of difficulty, I'll say, or how much work you got to do. If I had 2 points, I still need a slope and a point. I have to calculate the slope myself first, and then I have to solve for b. I just made those up, so who knows? Here's where I keep making these up and I get messy fractions. We'll see what happens. So my slope, make sure I get my y values, 5 minus -3. 5 minus -3. I'll start here again for x, 6 minus 4. Ooh, I think I'll get a nice number. Which is minus, a minus is really plus. 5 plus 3, 8/2. I got a slope of 4, which I'll probably use as 4/1 in a minute. Oh. Slope of 4. So I had to calculate the slope myself first. Right? Now I've got the slope. I'm going to use one of the points to solve for b. And I know if this slope is, the slope always multiplies the x value. All right, it's good to kind of understand that. Right, the slope is always multiplying x. So, gee, which x value is going to work better with that? Actually, it doesn't matter when it's a whole number. But if it was a fraction, this was a fraction, here's where you want to kind of say, well, does that fraction work better with one of the x's versus the other? Here it's not going to matter, but 4 for slope times 4 for x plus b. If they're integers or whole numbers, they stay whole numbers. It's kind of nice. Solving for that b, let's get rid of 16. -19 is my y-intercept. And so now, final answer, put it together with the slope I calculated and the y-intercept. There would be the equation. If I'd chosen this other point, you know, I would have had a 5 instead of -3, and I multiply by 6, it would still have turned out to be -19. Doesn't matter which point you use. Just maybe, if you think about it, one might be easier than the other to work with. I'm going to solve for b step. All right. Kind of the last method, which I think you probably saw in some homework, is if I've got the graph. So if I've got a graph, And let's see, I better make myself a couple numbers I can read. So I'm just gonna do that real quick here. I'm looking at the graph, write the equation of that line. I still need a point and a slope. All right, well, I'm reading the graph, and it's a nice enough graph. Maybe I can find the y-intercept, and I can count squares to find the slope. Let's see, from here, I went 1, 2, 3, up, and then I went over 1, 2, 3, 4. So there was my slope, was 3/4. Now, if it's not the y-intercept, right? If you're reading your graph, like some word problems that I think maybe you were asked to deal with, were really kind of like the last problem, the last one I just did, right? When he makes 5, it costs $200, and when he makes 8, it costs $600. Find the equation of that line. All right, well, for this quantity, you get that total. For this quantity, you get that total. That's really a way to tell you two different x's and y's, two different points. Now I'd have to calculate the slope and solve for b. So I kind of went off on a tangent there, but here, from my graph, I know the slope and the y-intercept, and I could say, oh, this one's 3/4 x plus 2. This was a different concept. That was, I know that you had at least one word problem, kind of like that. A manufacturer, when they make this many items, it costs them so much to make, and when they make this many items, it costs so much to make. Write the equation. So that's trying to tell you two x, y pairs. You also had you had one, at least somebody asked me a question, and I forget if it was the forum or just a message, where they referred to years, since 1987, right? The values changed since 1987, but they said, call 1987 times 0. So this is really counting time, right? X-axis is counting time. Very typical of problems using years. They say, okay, here's the start of our story in 1987. So 1987 is really 0. That is the y-intercept. And so whatever your value here is, that's the y-intercept in 1987. You don't ever use the number 1987. That's, that's 0,300 is my y-intercept for this problem. I'm just making up on the fly here. But then if I'm out here at 1993, what's my p-value? Well, 8, 9, 90, 1, 2, 3, 1, 2, 3, 4, 5, 6. X is a 6. Do that better, Steve. All right, in 1993, I'm using an x value of 6. I'm counting from 1987. Again, things you might run into in an application with word problem. And here they might say, in 1993, it was down to 150. Write the equation of that line. Well, I do know my y-intercept, but I'd have to calculate my slope there, right? Now, I'll finish that up just because I did it. All right, what's the slope? What I just came up with. I started here, and I went down. I called that 150. So I went down 150, and I went over 6. What's that? 6 times 25, so negative 25. There's my slope, negative 25. And kind of going off a little bit. Gee, interpret. What does that slope mean? If those were dollars, right? What does that slope mean? The value is decreasing by $25 per year, right? going down $25 a year. That's dollars per year. That's what the units y over x tell you, like miles per hour, dollars per year. It's going, and it has to be going down. Something's losing value for some reason. All right, but that was all about, I think, reading the graph there. All right, yeah, from the graph, figure out the intercept if you can, or at some other point, and then the slope. Okay, then are those two lines parallel or perpendicular or neither? Maybe there's nothing special about them. Maybe I made it up wrong. Okay, what's the deal with parallel lines? Same slope. So I need to figure out what the slopes of these two different lines are. This one, easy, 2/3, there it is. All right, there's my m value. This one, I'm going to do some work and rearrange it so it's in that shape, so I can see clearly what the slope value is. I'm going to solve it for y. So I'll subtract the x's. Leaves negative 3y. And I'll put the x's first. All right. Solve for y, I'm going to divide everything by negative 3. Boy, I made myself a nice number over there. Negative divided by negative is positive 2/3 minus 3. Oh, this one has a slope of 2/3 also. These two lines are parallel. All right. Parallel, same slope. They often will hide one like this, is what I'm getting at. Right? You got to do some work to know what that slope is. I made that up. I have enough experience. I know how to kind of do it in my head. We're not going to try and get you there. Parallel, perpendicular, or neither. Parallel, we know, same slopes. Hopefully you understand that, same slope. Perpendicular, that was two differences in the slope. Opposite signs and reciprocals. The slopes have to have opposite signs and be reciprocals of each other. This one I know. 4/5. This one I'm going to solve for y. Let's subtract those x's. All right, subtract those x's. Now divide by that 4. Everything divide by 4. This one has negative 5/4 compared to positive 4/5. Opposite signs and reciprocals, perpendicular. Okay. Again, usually one you can figure out, you can just see, and the other one you got to do some work. Do that carefully so you can see. I hate to say, be careful, they might trick you, but you can think of it that way. You might do all that work and that's, oh, it's just positive 5/4 and that's positive 4/5. They're reciprocals, but they're not opposite signs. That would be a neither. There'd be nothing special about those two. But this one wasn't. So they are perpendicular. Okay. All right with that. What slope do I need to use if I want to write the equation of a line that's parallel to that one? Parallel, what does that mean? Oh, same slope. The slope I need is 5/6. What you got to be able to do is pull out that slope. You're asked for the full equation, there'd be some other point here. And then you'd use the slope that you've chosen with the point, solve for B. That process we've done a few times. What slope would I use if I wanted to write the equation of a line perpendicular to that one? What slope would it have to have? Perpendicular. This one has 5/6. What's perpendicular to that? Opposite sign, reciprocal. Perpendicular would have to be opposite sign and reciprocal. And again, if you get a point to use, you could solve for B. Use the new slope. Once you've decided on the slope that you're going to use, don't do anything with the original equation. You see people try to plug in the 7 or something. All we want is that slope and throw it away. Right? All we want is the slope. All right, let's see. Okay, here, I'll keep going. I wrote it out. See, a wedding planner, or maybe stationery, whatever, charges $35 plus $1.80 per invitation to write your wedding invitations. Write the equation that you could use to describe your cost for a certain number of wedding invitations. An equation that describes the final cost in terms of a number of invitations. What kind of information is this problem telling you? I have to write an equation. I need a point and a slope. Do I know a point? This is an example of, there's some fixed fee. Just for coming in the office and talking to this person, haha, they're charging me $35 even if I don't order any invitations. But then for every invitation I order, it's $1.80 per invitation. This is almost like a clue that that's your slope. Right? If you get a rate, something per this, that's your slope. Okay. Y-intercept, slope. See how I pulled that out of the word problem I didn't exactly make up. I think it's out of the text someplace. But now I can say, oh, and be careful. A problem might say use N for number of invitations and C for cost. I could say the cost equals, and here the order shouldn't matter. I could say, well, I know it's a $35 fixed fee plus $1.80 for every invitation I order. There would be an equation. Now, if I reverse those 180 and plus 35, that should be totally fine. Mom gets picky, I'll go in and fix it. I'll give it to you. So there would be like a part one possibly for that question. It's almost given to you in the problem, but what does a slope mean? Well, you add $1.80 for every additional, $1.80 per invitation. Or I sort of talked it through. If you don't order any, what's the basic charge? It'd be kind of odd, but you got basic charge, y-intercept, right? $35. If you order 100 invitations, what's your cost? If you order 100 invitations, you got to know, oh, that's a number I plug in for n, right? I order 100 of them. What's your cost? And let's see, 180, right? 180 plus 35. $215. Why would I mark that partly wrong if you did that on paper? What am I getting at? What's the cost? $215. Oh, wait, I got a bunch of change in my car. Let me get all the pennies. $215. No, that's $215 units. That's just making that point. Be careful. Again, mom's usually pretty good about that for you, but like on a hand in homework problem, you got to put some units on your application problems. Now, we got through that whole list, plus a few applications. All right. I thought that was a pretty good review. Now, nobody stopped me, but you can always come back here. And if you, of course, you should really work through, you got to finish 4.6 before that test, right? If you haven't already, you should, right? It's not due till Monday because I always give you the week. And strongly encourage you to work through the review, at least one of them, for this chapter, for this section. And then Monday, as usual, log in and start the test when you're ready. You get that hour, and then send me your scratch work, as always. And I'll be watching today, tomorrow, and even today and tomorrow for questions, and even Thursday if something isn't working. You let me know. Okay. All right. Well, we made it. We're out of time, and I got through it all. I felt pretty good about that. Okay. Well, good luck, folks, as always. And send me your questions if you have them. And I'll see you on next Monday, and we will start our last chapter. Okay. Have a good couple days, and see you next time.
Thank you, Steve.
You're very welcome. Thanks. And goodbye.